Reviewing some old projects, I thought I should make a quick video for personal reference before they are also lost to time, like so many other projects. With this, I'm also practicing my video making skills as well. Some things to remember before watching this. These, let's call them projects, stretch from before I finished with school to more recently. Back then, the internet was just starting out, not a lot of online help like we have today. You just had to keep on hacking until it worked. Most of these had no grand plan. Was just for fun, either a nice challenge or a feeling of I want to build that. Although I developed my skills coding, looking back it seems like styling was not yet a thing, but then again, all the 90s websites were just as bad. This video mostly presents the projects chronologically, but some jumps are made to show revisiting of projects. So, let's start. I called this game Peacemaster. It was a physical game that I don't know the name of, so I developed a digital version. I can still remember developing this as a Java applet back when that was popular. After seeing the movie Pushing Tin, I built this simple ATC game. The idea is simple. Planes can enter your airspace from any of the 8 directions and also from the center, which was an airport. All the planes that enter require to be guided to their 2 direction and height. Can't remember why I chose 1 to 8,000 for height. We have a timer showing the current game time and also the time each flight arrives, which on this difficulty is every 30 seconds. You can skip to the next 30 seconds with a spacebar. There we go. Looks like everybody is going where they were supposed to. This is as simple as it gets. Use the mouse to shoot a target before it disappears. For context, this is what I built in 1999, and by the early 2000s I've already built 2 large-scale rendering engines with animations. I will be skipping ahead in time to show the last full 3D rendering engine I wrote before switching to GLC, an open source engine. This was built in my second 3D engine I wrote, but I'm jumping ahead over the first. But that's just to show the progression from the basic shooter game I just presented to this example. This game has 4 areas with 4 different game types. Let's look at the target shooter first. An original gun model. I actually think this was created by a friend of mine in my first 3D engine, but I'll get to that later on in this video. I see I stole, or let's say rather I borrowed the Counter-Strike rifle for this one. Got the silhouette targets from a website I built for a shooting club years earlier. I hear that it's not just the game models that I borrowed. It sounds like I got the hit and miss sounds from the game Worms. This rifle scope really needs some more granularity. Next, let's look at the urban shooter. The idea of these rooms before the shooting range is that you can select your weapon before you play the game. Another borrowed gun graphic I see. Look at the windows break. That's a nice touch. Was going to put more dynamic elements like this into the game. Next will be saloon shooter. Really original naming schemes I see. Let's not mention that gun graphic. Okay, that's nice. Continuing the naming theme of shooter, let's look at skeet shooter. Another one of those original models. Looks like a Hollywood movie, no reloading required. This is quite a nice game, enjoyed playing it again, but let's get back in time. Based on a Nintendo game Duck Hunt, developed this using DirectX. This was loaded with ideas and styling to see what works best, but I never polished it. Had 4 game types, time limit, duck mist, die hard duck. Technically it was very simple. The mouse cursor controls the position of the various layers. See how I made the layers move differently to simulate perspective. Can still remember being mesmerized watching the duck fly for about 10 minutes or so after I coded it to fly randomly. Even though technically this was a very simple build, to me personally this is one of my creations I will always remember. Speaking about how simple the core mechanics are, we can actually visualize it. A friend came to me in 2012, or that is what the date on the file says, to help his daughter build a school project in the program Scratch. A program until then I've never heard of. And amazingly, Scratch is still around, online though, and even more amazing, I still have the files, and it still opens my files. I think I built this car game for her to let her drive around with the arrow buttons. It had some mechanics for her project. But of course, I still had the duck images from years ago, so obviously I had to make the duck fly again. Here we go. Here is all the logic that makes a duck fly. I see the angle of the duck is very extreme, but it works. The game even has interaction, where you can shoot the duck and it increases your level and then makes the duck faster, until you can't hit it anymore. This game was built around a concept of selecting irregular shapes, but I will get back to that as I play around. You can play 5 different dart games with 4 players. So, while I enjoy a game of 2-player killer with myself, let's discuss this selection technique. The concept is very simple. Paint the selectable areas in different RGB values in an off-screen buffer. Then decode the pixel color under the mouse cursor and you will find the selectable object. It's a simple concept, but very powerful. Testing this idea led to this game. I could not think of another game that this concept would apply to. I don't even play darts. Saw this game somewhere, obviously had to build it. This happened quite often. I see a game or have a small idea, and rather than playing and enjoying it, I build it. This game is simple. You can only jump over another ball, and by doing so, remove it from the board. You have to end up with only one ball to win the game. Classic Snake game. As far as cool yet weird ideas for a game goes, Snake has to be up there. Remember playing this game on an old Nickelodeon CD. I see there is still some logic debug buttons left. This is to show the legal moves of each player and then also show the best move. What can I say about this game? Nothing new. Remember playing the Microsoft version of this game in Computer Lab because I was so far ahead with my assignments. Just showing this for its cool interface because it was nowhere near finished as it was intended as a network game. Both the destroyer and submarine's controls and interfaces was implemented. Networking code were never completed. Obviously a classic board game. This one is completely implemented for single player. Can remember implementing a proper AI for this, with little more logic than simple random selections. But I can see my styling and color contrast was way off. Another classic, fully implemented custom rule set, just needs more interface dynamics for better feedback. Also use the selection mechanism of the dart game discussed earlier. Fully implemented one-player chess. The idea was that a friend would also implement the chess game and then we'd have them play against each other to see who implemented the best strategies. But he could never get this to work in single player. But okay, in his defense, he used Visual Basic. Shots fired. This was also a physical game that I tried to recreate, but I never got finished with it or even came close. But I revisited years later to build a special solver. So not really a game, more a brute force solving method. Then got into RC helicopters and obviously wrote all sorts of related software. This is one that I found in the archives, 3D Heelys. This started my 3D engine journey with this first iteration of the engine that was nothing special beyond the simple third dimension drawing. Extracted these models from flight simulator software. Technically this engine used software rendering as it directly drew the pixels. I went about building a very basic 3D designer which allows you to build a 3D object in a very primitive way. But I want to pause here and explain how we had to build 3D objects before we had modeling software. You start with physical graph paper that'll make your drawing and reading of the values easier. Let's say you want to draw this 3D object. We then draw at least 3 views depending on the level of detail of the object, from the front, from the side, and from above, to read the 3 axes of data. Then we decide where the origin point is, the 0, 0, 0 point. Usually it's in the center of the object where the object will normally pivot. We then read the 3 dimensions of data from the graph paper and feed that into the designer. This gives us a list of points. Then we have to create a surface from those points. This is done by linking 3 or 4 points. Nowadays we only use 3 points. The sequence of the 3 points determines the direction in which the surface faces. This is important as we do not draw faces not facing the camera. This is called backface culling. You follow the process until your volumetric object is made. Now, keep this process in mind when you have a look at these objects that was created in this designer. This solution was part of a doctoral degree for a university lecturer, where I developed a tool, Logical Structural Thinking, an early e-learning tool. It was 2 apps, the creator and the viewer. The creator is where the questions were created. The viewer is the app the students use to answer the questions. Structure of the questions was set up as: the question's format could be textual, textual with image, or textual with 3D object. The answers format was multiple choice, where there was 5 answers of text, image, or 3D objects. Can also provide up to 3 hints and set the question difficulty. Each one of these sections had self-contained editors, like the photo editor. Looks primitive, but remember, this was 2003. Also, the 3D object editor was to build all sorts of 3D scenes for spatial questions. Another interesting part was the 10 grams, where you could build 2D scenes with its own editor. The system will track the scores over a period of time per student for analytics. Back then, this was a huge project for my skill set and tools. Continuing with the early e-learning trend, I was approached to develop training software for butchers, being recommended by the university because of LST. Developed a tool called Meat Processing Tutor, where the software teaches the student to process meat into the various cuts for the beef forequarter, hindquarter, sheep and pork. It has a complete training course along with a comprehensive assessment facility, even going so far as to let the students show the actual cut. This project is in the advanced stages of redevelopment with newer technology and being web-based. This was another attempt at a commercial software solution. It takes a photograph of a vehicle. You set up a bit of information and then you can view any number of mags on the vehicle. It could even show the wheels turning, but could never successfully market this product. Small project I wrote for a French university project to do time difference calculations. Had at least half a dozen of these type of projects on various levels, school, university, even going back to Pascal code. Unfortunately, those exist only in my memory now. Started playing around with GLScene, an open source 3D engine, along with Open Dynamics engine, an open source physics engine. Produced a couple of interesting games, like this foosball. Besides the field, created all the players in 3D Max Studio. Another GLScene project. Cell phones had this new orientation sensor and I had to build something similar in software, obviously. So I created models and wrote a couple of apps. This game was on the phone, where you had to get the yellow ball to the green circle and avoid the grey circles as the ball will fall in. This was based on a game we used to play in the late 90s. That was gifted to me by a friend. The lower you fly, the faster you go to get the best time, while passing all the gates. But if you fly too low and you touch the ground, you will slow down again. Enjoyed a UAV documentary, so I developed this called Mosquito in Afrikaans. Unfortunately, could only find the early backup of the game and a proof of concept of flying and shooting targets. Wanted to leave this video out because I could not find the most recent version. Then I thought there's still enough to show what the app was. Because of the missing release, the video is cut up into 2 different apps to show all the features. For some reason, the mouse does not capture in the release I have. So I have spliced in the proof of concept version. I actually wanted to do a rebuild of the software, but there were some major upgrades in the GL Scene engine. So I'll leave that for now. After embedding a Google static map onto a website I built, I just want to pause here again and quickly explain what Google static map is. It's a clever way of allowing a website to embed a single image of Google Earth Maps onto its page. No need for JavaScript. Now that we have a basic idea of what Google Static Map is, let's look at the plan. Looking at the API call, you provided with the coordinates along with the zoom level. This gave me an idea of requesting maps in a grid and built some sort of offline map control. So I scoured the net to find the map projection Google uses. When I found it, I built the basic GIS framework around the projection formula. Turns out it was a modified Mercator projection. Got it to work perfectly. Built some cool extra features to make it a better experience, like a threaded image loader, either from the disk or on HTTP requests. Also, when the current position in the zoom level is not yet available locally, I iterate through the lower levels of zoom until I find a local image. Using that image, I copy the section of the image to the grid where the image is not available. This obviously produces a lower resolution map section, but there is not a gap in the map because of the missing image. I can still remember the static map request had a built-in limit on the number of images that you can request, because they send you one of these. I see I still have one of these within the images when I built it back then. I don't know if the limit still exists today. Now, to make this video, I ran the software again. When I requested an image, Google replied with a 403 error. Turns out they require you to use an API key for the static maps now. This was not the case back then. So for fun, I obtained a static maps API key and it works again. That concludes our walk down memory lane. The most recent project seems to slow down. Beyond my work commitments, this is because I started working on electronic projects. There's a whole bunch of those. Might make a video. But for now, thanks for watching. This is Hansie Grobler signing out.